Hey everybody, Lars here. This is a special review video. It really doesn't go over the slides, but we're going to go over a website that I really like to give students around this time called Project Euler. And there's a little background to the story. So before we actually go to the site and take a look at it, I'll tell you the background. Around 7 years ago, I built my lab over in the computer science department called the Cave. And students used to walk into the cave and say, I want to learn Python. Is there a Python class I can take? Now, at the time, there isn't. I mean, now there's a Python class in Camden, and there's this class, but this is a graduate level class. There still really isn't an undergraduate level class where somebody can go learn Python, which is a little bit on the silly side if you ask me, but that is an argument for another time. So we used to tell people, go to learn Python the hard way, because we were aware of learn Python the hard way at the time. And that's one of the resources that you're going to be looking at for your midterm project. And after you go through learn Python the hard way, go to this website we have called Project Euler. And you're going to see it in a minute. And Project Euler, at the time, it was just a little bit over 500. Now I think it's 600. Had 600 number theory problems that lend themselves to being solved with computer programming. It doesn't have to be Python. Could be C++, could be Java, could be any programming language. But you'll see when you look at some of the problems, they lend themselves to being solved with computer programming. So we would tell people, hey, go through Learn Python the hard way. When you get through Learn Python the hard way, go to Project Euler and do about the first 50 problems. And if you can work your way through the top 50 problems, as you'll see when we go to the site and we take a look, back in the day, that would put you like in the top 5% of people who used Project Euler. And it's good practice. And like I usually say to people, you learn how to program for something. Either you want to use it at work, or you want to do a project, or you want to become a computer scientist or a computer programmer, and you need that in your tool belt. After students would do Learn Python the hard way and then 50 problems at Project Euler, we would tell them, okay, now go do what you want to do. Go do your thing. Don't say, what next class should I take? What's the next book I should do? Blah, blah. At some point, you got to stop and you got to go do what you want to do. All right? Enough books, enough hand-holding. You got to go do what you got to do. You're not there yet, but you're going to be soon, but you're not there. When you get there, you'll know. You got to go off and do what you got to do. Go do what you learned it. If you're in an analytics track, you want to learn R and Python, and you want to use it towards doing data science and big data stuff. If you want to be a computer programmer or a computer scientist, you use it for those purposes, things along those lines. So, what we would do is we would always send our kids to Project Euler, and I think here, I have it up right there. Project Euler right here. It looks like Euler. It is pronounced Euler. Trust me on that one. And what it does, if you go to archives, you'll see you have lists and lists and lists of programs, and you can just click on one, coin sums, and you can see the different problems that they have. We are going to look at number 6. Hold on a second. Let's go. 600 on the nose. There are exactly 600 problems at Euler right now. Now, I could log in as myself, but I'm not going to. I actually set up a login for the class. So when we solve our problem, we are going to go into Project Euler and see if we're correct. What do I want to do? I want to go here. Now, one thing I am going to say right now at the very beginning of the video is that what I'm doing right now is totally wrong. I shouldn't be doing it, because you're really not supposed to solve Euler programs and then put the solutions online. You want it to be fresh and ready for somebody who wants to do these problems without having the answers laying all about. And it's no secret. If you Google Euler space 23 space Python, it'll take you to Stack Overflow, and someone will have the solution for number 23, non-abundant sums or whatever. About the first 100 of these problems, they're pretty famous, and most computer programmers and computer science students at Rutgers know about Project Euler and boom, boom, boom. And if you go to Stack Overflow, in Java, C++, and Python, although Python's getting really popular with the Project Euler ones. All the solutions are online. Okay, I'm not helping any by doing number 6 and making a video about it, but it's kind of easy and it suits a purpose for this class, so I always do it every semester. But I shouldn't be. I shouldn't be advertising this or doing anything like this. So if we look at number 6, we see the sum of the squares of the first 10 numbers is 1 squared plus 2 squared plus 3 squared, blah, 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 all the way forward is 385. Okay, great. Square of the sum of the first 10 natural numbers is, add them all up, and then square them, so 55 squared is 3025. I take the difference, and I get 2640. Okay, so there's a worked example right there, and all of a sudden at the very bottom it says, now find the difference between the sum of the squares of the first 100 natural numbers and their square of the sum. Okay? So, if you think about it, there's a pretty easy way we can do this with programming because we have enough tools in our tool belt now. We've got loops, we've got variables, we've got, if then, we've got some different ways to come to solve problems now. So we've got the tools to do something like that. So what I'm going to do is I'm going to quick craft a program that solves this for 10 and then checks the answer to make sure my algorithm is working. And then, instead of looping up to 10, I'll just change the number of the loop up to 100 and see if I can't get that answer. All right? All right. Then we are starting from scratch. It's good to see everything start from scratch from now to then. Now and again, I meant to say. So I got Python 3.6. I'm going to go there. I'm going to say new file. I'm just going to say Euler 6, my name, and then we'll get going. Let me save it. I will save it in, where am I going to save it? Python Data Science, fall 2017, and I'll just call it Euler 6. All right, so what's the first thing I want to do? Well, I know what the first thing I want to do. Usually when I do an Euler problem is I will just go grab the beastie, copy, and then paste it right into the code so that I actually have a description of the problem right there. Okay, so now I have it right there in front of me. This is 1 squared, 2 squared, so the notation's a little funky looking, but that's okay. I think I know what's going on here. All right, what's the first thing I want to find out with my program? The sum of the squares of the first 10 natural numbers is, so I want the sum of the squares. So I will say find the sum of the squares. Let's get some room here. And here, let's put that down there. Put this over here. So we get a little area going, and we are in Fat City. All right, what do I want to do? I think the first thing I'm going to do is I'm going to set up a variable, SOSQ, for sum of squares. I'm going to make it equal to 0. Then I'm going to say for I in range, what do I want? I want to start at 1. It's the first thing I don't want, 11, because I want to go to 10. I'm going to say let sum of squares equal sum of squares plus I squared. Because I will come in as 1, I square it, that's 1, it'll add it to the variable because I'm setting up an accumulator. Second time through it'll be 2. 2 squared, 4. Add it to the accumulator. Boom, boom, boom. Let's see what we get. Print. The sum of the squares is colon. The sum of the squares is 385. So that is correct. We are in good shape. All right, so boom, 4 lines. We already got the first part. All right, because at the end of the day, this is Euler problem 6, but it's not one problem, right? It's 3 problems. Because first I have to find the sum of the square, then I have to find the square of the sum, then I have to find the difference. So it's really 3 different problems, and you'll find out when you start problem solving, especially with computer programming, you're going to have problems like this. Like everything is a compound problem, and you have to break it down and solve things one at a time, and then take those solutions and put them together at the end for big solutions. So now the second thing I want to do, I've got that sum of squares. Now I want to find the square of the sum, but I think I'm going to be able to let some of this code do double duty. So I'm going to copy it, and then I'm going to say find the square of the sum. And I'm going to change the variable name to square of sum and make it 0. I still want to do that. I'm going to change the variable names here. Square of sum equals square of sum. But here's a little bit of a difference. I don't want to square it anymore. I just want to add everything up. And then when I'm done adding it up, I want to take square of sum and make it equal to square of sum squared. I want to add it up first, and then I want to do it. And then what I want to print out is the square of the sum is square of sum. Run that. All right, we're in good shape. 385, 30, 25. I check up here. 385, 30, 25. All right, I'm getting the right answers here. So I'm just going to do that last part right in a print statement. I'm going to say the difference is, comma, and then just say square of sum minus sum of square. And then when I run it, I get, where's that comma coming from? How dare you mess up my output. So we get the sum of squares is 385. Cool. Square of the sum is 3025, cool, and the difference is 2640, and as we can see up here in our example, that is correct for the first 10 natural numbers, okay? So we got a nice little piece of code here, all right? Solves our problem. Finds the square of the sum, finds the sum of the square, or the square of the sums, I'm sorry, and then it finds the difference. So that works out pretty well. Print the difference. We'll just put that there so we have all three of our different sections put out together. I will keep this lowercase to keep my OCD happy. Now, we're not done yet, because think about it. Now find the difference between the sum of the squares of the first 100 natural numbers. But because we did it in a computer program, it's easy. What do we have to do? The reason we do 1 to 10 here is because of our range, and the reason we do 1 to 10 here is because of our range. If I want to go to 100, all I do is make it go to 101, the first thing I don't want in both of these ranges. I rerun, boom, I get a new answer. See? That's even too much for me. I'm going to do this. I'm going to create a variable called limit. I'm going to make it equal to 10. And then I'm going to use it for the back end of my ranges. Then I only have to change it in one place. Now, what we did right there, is that going to work? It's not. That was a pregnant pause for you to figure things out for yourself, by the way, just in case you were wondering. It won't, because what is limit? 10. Well, we want to go to 10, but we know in Python, at the end of a range, it's exclusive. It's the first thing we don't want. So that range would only go from 1 to 9, and that wouldn't give us the right answer. So what we want to do, a little trick in the Python world, is we're just going to add 1 to limit at the end. So that way the code is nice and reasonable. My limit is 10 or my limit is 100. But I'm adding the 1 there to get my exclusive limit so that when I run it, I'm back to my 2640 for that. And now, just by adding the 0 in one spot and changing that variable, I get it for 100. Okay? So that's a nice little piece of code. And that, I am pretty sure, is the solution to Euler 6. But we have to go check that out. So what I'm going to do is I'm going to highlight the answer we get for the first 100 natural numbers. I'm going to copy it. And then we're going to go log in at Euler. Let's go. Sign in. I created PMDS-F2017. An ID for us, and the password is capital P, capital C, L-A-S-S, Python class or P class, and then 17, okay? Then you put in 8855, the number, so it knows you're not a bot. Then you sign in, And then, if the Euler gods are with us, there you can go, logged in as PMDS F 2017. So you have the password to this. If you want to log in here and start solving some of the Project Eulers, and as a class we can build on this, go right ahead. Go in there and solve some of them. That first one should be rather familiar. Knocking, nod, nod, wink, wink. I'm going to go to number 6. And now that I have a user ID and I'm logged in, you can see it has a space for my answer. And then the confirmation code is this right here, so that it knows that we're not a bot. Okay? So there's the thing. The answer, I'm going to paste in there, 251-641-50. And then the confirmation code would be 39180. And then when I hit check, it's going to check the answer. And when you get something right in Project Euler, it comes back with a big green check mark. And when you're a computer programmer, like I always say, that big green check mark is one of the nice little buzzes that one gets, because that means you got the right answer. So, check. And I'm pretty sure it's correct. And it is. You can see our big green check mark. Congratulations. The answer we gave is correct. We are the 369,000th blah, blah, blah person to have solved the problem. Okay? But now, we're on record. So now I can go to the progress bar up here. And I can see, hey, I've solved that one. It tells me the difficulty rating, which is very high, and other people who have done it. And if I solve 25 problems, I get to that level, and then 50 for that level, and then 75. Then there's special awards down here. You can do the primes if you answer all the primes. There's easy as pi if you answer the pi numbers, 14, 15, 92, 65, 35. There's a whole bunch of different trick ones you can do. Okay? You can also go to stats and look at how many people have solved the different problems. Okay? You can see that of all the people who solve problems here, 46% have solved number 6. And if you go down here, we used to tell people to solve the top 50. And if you solve the top 50, it puts you in the top 5.7% of people who use Project Euler. You have to get 54 questions now to be a top 5%er, which is about the same as it was, because back in the day, 2010, 2011-ish, we were telling people to do the first 50, and it would make you a 5%er. Okay? And then you have to what? You have to do 280 to become a 1%er, which is kind of hard. Oh, no, that's not true. That's 0.01%. Oh, my God, that's... I was going to say. You have to do 114. Forgive me, I'm coming down with a cold. It's always got to be something, right? It was hot. It was boiling hot around here. And then all of a sudden it decided to be autumn. Hey, Alexa, tell me about the weather, please.
Currently, in Metuchen it's 64 degrees with clear skies. Tonight, you can expect lots of clouds with showers, with a low of 53 degrees.
Showers, 53 degrees, goodness. That's, I was going to say 64, that's usually what I set my AC for. But low 50s? Rain? Wasn't ready for that. There's a Rutgers game tomorrow. It's not going to rain for the Rutgers game tomorrow. Alexa, is it going to rain during the Rutgers game tomorrow?
I'm not sure.
I got to ask things a certain way with dear Alexa. All right. So, you can look up stats on the different problems that you solve. You can look up your progress. You can look up all kinds of things. All right? Project Euler is really cool. All right. Now, yeah, the first 100 or so, the answers are online. Don't go look. Because you can, and I know you're gonna, because I would do it. And try them out. Try them out. Think how you would solve them. Use pen, use paper. Do it like a puzzle. Do it like a game. At the end of the day, that's all this is. It's like a puzzle. It's like solving puzzles. It's fun. And do your best. And then if you really run into a rut, maybe take a look at some ideas and stuff online. Don't go look at the code right away. All right? Sometimes you go look at the code, you don't even understand what it's doing. And later, you're going to see it's pretty cool, the different tools that you're going to use in the Python tools. There's a thing called iteration tools you'll learn how to use, and you're going to learn how to use tools to do things with prime numbers, and that's kind of cool too. So Euler's good. Euler, you will get your chops up quick if you play around with Euler. And now we have a class account, so you can go in and solve different problems if your heart desires. All right? So definitely go to, but you know what? You don't, at the end of the day, you don't have to do it with the class account. Go set up your own account and just start solving problems. I mean, there's 600 of them out there waiting for you to practice and waiting for you to do different things with. All right? Euler's neat. So definitely make it one of the things you use to practice when you do your Python stuff. All right, enough of that. Announcements. I'm shooting this on Friday night. The unit's going to end a week from yesterday. So in 6 days, on Thursday, I think is October 5th. The 2 assignments, you've already seen the assignments. They're not long. They take a little bit of thought. So make sure you think and you try things and you are confident before you hand it in. Forum post, make sure it gets in there by Sunday night so people have a chance to read it. Okay? I can't have forum posts going in the night before a unit ends. It's got to be 3 or 4 days beforehand. This go round, I'm saying Sunday night. Get it in there by Sunday night. So people can start looking at things on Monday and maybe reading what other people's ideas are and answering other people's posts and doing things along those lines, all right? Quiz is going to be Thursday, but as usual, I will open it at 8 p.m. Wednesday night. So you'll have 4 hours Wednesday night, all day Thursday, and then an extra hour at the end. So I'll probably close at 1 a.m. Friday, all right? And then take a day off, and then when the weekend starts, we'll get going on Unit 3. Unit 3 is a big boy. Unit 3 is going to be interesting and fun, and you should know. Things are starting to get interesting now because now you can solve problems. Take the skills that you have and look at some of those Euler problems and look at some of the problems in the Zell book and realize that now you're at the point where you can start thinking and you can start taking the logic in your mind and codifying it and putting it down in programs. Okay? All right, then I'm going to get out of here. You have a great weekend. I am going to go tomorrow to High Point Solution Stadium and sit in there while we get the crap beat out of us by Ohio State. Ohio State is favored by 30 last time I looked. A couple days ago it was 29. Now it's 30. Schiano's coming back. Schiano is an assistant on the Ohio State staff. So Greg Schiano will be back in the building. There was an article about him and all he did for the football team when he was here. All right, you have a good weekend. I'm going to get out of here. I'll be in touch. I'll do some announcements and I'll do some other things. Don't forget, class, 5 o'clock on Tuesday. All right? Come a little later. I don't want you to run into traffic. I don't want you to have to leave classes early and all of that nonsense. So come by 5 o'clock. All right? All right, good. Then I'll talk to you later. You be good. Bye.